Hey guys, IE.RVT here, and we're currently looking at Module 5, Homework A, Tab 2, Part 4. This is stored energy density. So we already know that the total energy stored in the plate capacitor is going to be U of C is equal to 1/2, I'm going to write this as a better U, 1/2 times C times V squared. And from earlier we also know that capacitance C is related to area A and the separation D of the plates is going to be C is equal to epsilon 0 times by A all divided by D. So now we know that the energy per unit volume, U sub E, is the energy stored in the capacitor divided by the volume between the plates. The volume between the plates is simply the area A of the plates times the separation distance D. So we have that, I'm going to go ahead and write this in green. Volume is equal to A times D. And so pretty much the energy per unit volume is going to turn into, using what we know above, U sub E is equal to U sub C all divided by volume, which is equal to 1/2 times C times V squared all divided by A times D. And so if we remember from a previous part, we know that V is equal to E times D, where V is voltage, E is electric field, and plate separation is D. So if we substitute V is equal to E times D into the expression for U of C up above, we're going to get U of C is equal to 1/2 times C times E times D squared. And we can go ahead and substitute C is equal to epsilon 0 times A all divided by D. And we're going to go ahead and get U of C is equal to 1/2 times epsilon 0 times A divided by D. It's not a very good epsilon. And then multiplied by E times D squared. And now we can go ahead and simplify that to be U of C is equal to 1/2 times epsilon 0 times A times D times E squared. And so now we can divide the total energy by the volume A times D. So it's going to be U sub E is equal to U of C all divided by A times D is equal to 1/2 times epsilon 0 times A times D times E squared all divided by A times D. So now we can go ahead and cancel out to A times D, and then now we're pretty much going to be left with U sub E is equal to 1/2 times epsilon 0 times E squared. And I believe that should be our final answer that works in SNAP physics. So pretty much what this tells us is that the energy per unit volume in the electric field of a capacitor depends on the electric field strength E and the vacuum permittivity epsilon 0. And the energy stored in the capacitor is distributed throughout the volume between the plates where the electric field exists. This energy is proportional to the square of the electric field strength.